Hello and welcome. My name is Yash Jangir and today I'm presenting my research that I conducted this summer as part of Robotics Institute Summer Scholars Program under Professor Sebastian Scherer. My research topic was visual servoing for aerial manipulation and title of my project is ELVIS, Efficient Line Detection and Tracking for Visual Servoing. I will start by briefly discussing the motivation behind the project. Visual servoing enables UAVs to perform different tasks. For example, bridge inspection, power line inspection, and wall painting etc. without off-board sensing. Here, visual information is used as feedback for controllers which control UAV motion. Near walls and bridges, it can become very hard to use visual servoing due to presence of low textured surfaces and very less visual features and visual information. There may or may not be enough good features available for processing. A requirement arises for a robust and efficient visual feedback system which uses the information, which does not rely on smoothness of the surface and only relies on always available visual features which are present near walls and bridges. For this purpose, we propose an efficient edge and line detection based approach which leverages always available wall edges to provide feedback for servoing. This can enable UAVs to servo even around low textured surfaces. We track the equations of edge lines in image space as the multirotor moves in 3D space. These line equations can be used as feedback for pixel error based controller for servoing, hence improving visual servoing techniques. So how do we achieve this? In our methodology, we start by taking depth image as input for depth image based filter which returns a bounding box of target surface. We segment that surface from RGB image and only apply the line detection algorithm in the segmented image. This helps in reducing the processing time and filters the unwanted lines easily. We then perform clustering and final line equation processing and provide the line parameters as feedback. The above block diagram shows the same process. Let's discuss each part in more detail. For our depth image based filter, we first apply Gaussian and median filtering on depth image and then calculate surface normal image. For initialization of target surface, we assume that initially when we start, the camera center lies on the target surface. We then use that initialization point on the surface to perform a directional search to find bounding box for the target surface. We keep repeating this procedure every time while updating initial point as centroid of bounding box for next step. This results in tracking and boundary detection for target surface. We then use bounding box as mask and segment the RGB image for line detection. We apply Kenny edge detector and probabilistic Hough transform for line detection. This gives us lines which are detected in the segmented image. We then perform clustering using k-means in the final resultant lines and pass the final parameters for best estimates of edge lines. For our experimentation, we have used Intel RealSense D435 with ROS and haven't used any GPU for image processing. We take a random whiteboard as the target surface shown in the figure 1 with corresponding depth image shown in figure 2, and the bounding box is then generated using the normal image as seen in figure 3. In our results, we see that we remove about 90% of unwanted lines with our depth image based filter. The lines which are detected in full image can be seen in figure A, and our final results can be seen in figure B. We detect edge lines with very high accuracy and provide the line data at about 24 Hz for input image feed of about 30 frames per second. In our future work, we want to add some decimation, spatial, and temporal filtering in depth image. We want to use better clustering algorithms. We also want to remove initialization of target surface by introducing a small deep learning based architecture. I would like to thank WIS program coordinators Rachel Burchin and Professor John Dolan for their work this summer. I would also like to thank my mentors Dr. Jenny Gung and Dr. Sebastian Scherer for their mentorship this summer. Thank you and have a nice day.